Hi, this is Akash Srivastav. Welcome to my YouTube channel. So in this video, we will discuss some important theory questions which are from haloalkanes and haloarenes. So I would suggest that you can write in your copy along with watching the video. You can pause and write. The first question is, why is sulfuric acid not used during the reaction of alcohols with Ki? So the answer is H2SO4 converts Ki to I2, converts Ki to Hi, which then oxidized by it to I2. So I is not available for substitution. Next question. When haloalkanes is treated with KCN, it forms alkyl cyanide as main product, while when it is treated with AgCN, isocyanides are formed. So answer is KCl is ionic. When you put in water, cyanide ions are formed. So cyanide do the substitution reaction. In AgCN bond is covalent, which is strong. So Ag, we can say that Ag is attached to carbon, and carbon is not free to attack. So the attack is from nitrogen, and nitrogen is free, and isocyanide is formed as major product. Next question is, although chlorine is electronegative, it must be meta-directing, but it is seen that it is ortho-para-directing. So the answer is, due to the presence of lone pair on chlorine, it increases electron density at ortho and para positions. So you can show this by the help of these resonance structures. Next question, which among the three has the highest dipole moment? So you draw these structures and draw the dipole moment sign. So you will see that CCl4 has a zero dipole moment as it cancels out from all the sides. Next, CHCl2 and CHCl3, experimentally it has been seen that it looks like CHCl3 must have high dipole moment, but experimentally CHCl3 has lesser dipole moment, means overall the CH2Cl2 dipole moment cancels less than this CHCl3. That is CH2Cl2 has higher dipole moment. Next is, what are ambident nucleophiles? Some groups have two nucleophilic center. Like in the one of the previous question we saw KCN, AgCN, one form cyanide, one form isocyanide. Both have the same atoms, carbon and nitrogen, but they join from different atoms. So these type of groups which can join through two different atoms, we can say that two nucleophilic center are called ambident nucleophile. One more example is NO2 and ONO. Next question, the dipole moment of chlorobenzene is lower than that of cyclohexyl chloride. In this cyclohexyl chloride, first you draw the structures. In cyclohexyl chloride, you can show minus I effect. This chlorine is pulling the electron towards itself. So the dipole moment is along the direction of chlorine. Here also there is minus I effect, but due to the presence of lone pair and this benzene ring, this lone pair undergoes delocalization, and therefore dipole is distributed in two sides and cancels a bit. So it has less dipole moment, and cyclohexyl chloride has high dipole moment. What is the use of Freon 12 DDT carbon tetrachloride and iodoform? Freon 12 used in aerosol propellants, refrigeration. DDT effective against mosquitoes. CCl4 used in fire extinguisher as pyrene. CHI3 means iodoform, used as antiseptic. Out of these two compounds, C6H5CH2Cl and C6CH, which is more easily hydrolyzed. So C6H5 means benzene ring. So when this Cl is removed, one carbocation is formed on this CH2. So here there is one benzene ring, here there is two benzene ring. So this plus charge will get delocalized due to this presence of benzene rings. It means that it is getting stabilized. The more the benzene rings, the more stable the carbocation, and it is more easily hydrolyzed. So answer is this is more easily hydrolyzed because carbocation is stabilized by two phenyl rings. Phenyl means benzene rings. Why para-dichlorobenzene has higher melting point than ortho and meta? It is because of its symmetrical shape. It fits into crystal lattice better than ortho and meta isomers, which increases the boiling point. Next question. The treatment of alkyl chlorides with aqueous KOH leads to the formation of alcohols, but in presence of the question was with aqueous KOH it leads to alcohol, but in the presence of alcoholic OH, alkenes are formed. So the answer is in water KOH gives OH ions, which is a very good nucleophile, and substitution happens. In alcohol means organic like methanol, ethanol. In presence of KOH, alkoxide ions are formed. Means from methanol, means for example this is in presence of this OH, this hydrogen is taken and this negative charge comes on O. So it forms something like this CH3O minus, which is a strong base. Therefore elimination takes place. Alkyl halides, though polar, are immiscible with water. To mix with water completely, it must form hydrogen bonds. So the answer is it does not form hydrogen form. Therefore, now why Grignard reagents could not be prepared under anhydrous condition? Anhydrous means dry conditions. So Grignard reagents are highly reactive and react with any source of proton to give hydrocarbons. If your desired product is hydrocarbons, then it is okay, but if you are preparing something else, then you must avoid. So what is optically active compounds? Some compounds rotate plane polarized light in left or right direction. Those are called optically active compounds. What are chiral, achiral? If you see the mirror image of a compound, if it is same as the mirror image, then it is a chiral, and if it is different, means it cannot be superimposed, it means it is chiral. What are enantiomers? Stereoisomers related to each other as non-superimposable mirror image are called enantiomers. Means that chiral isomers, both the chiral isomers together are called enantiomers, and they rotate light in different directions. So if you take 50-50% of both the enantiomers, it is called racemic mixture, and the overall rotation is 0. What are Grignard reagents? Alkyl magnesium halide is called Grignard reagent. Thank you for watching. You write in your copy, then it will benefit the most.